Hello and welcome to this webinar on information standards to enable digital transformation of process industry. It is Eurostep, me, Torbjörn Holm, and Jonas Rosén, together with Touchless Consulting Group, TCG, that are presenting very relevant information standards for these purposes. We will divide this in three sections. I start first to talk about characterization of the selected standards. Jonas Rosén will present one of the standards called PLCS, Product Lifecycle Support. It's about the life cycle of assets. And then Anders Malmberg of TCG will talk about a very important standard and principle standard called 1346, and that's how to structure process plant data and how to identify objects in such a structure. But I start first with the characterization of the selected standards. What we will talk about is one standard called ISO 15926. The official name is Integration of Life Cycle Data for Process Plants, including oil and gas production facilities. And when they started their work, no one else in the world were talking about ontologies, and now everyone talks about it. But it is a generic ontology for process plants and oil and gas production facilities. It's a very theoretical, stringent standard, and its usage is growing more and more. One of the standards or de facto standards that's been utilizing the principles of ISO 15926 is something called CIFOS, Capital Facilities Information Handover Specification. It's about the exchange of standard data from an EPC or a project to the operator/owner in a way that the operator and the owner can utilize this in its asset management system without doing a lot of hands-on activities. This is a standard that's growing very fast in usage, and I will talk a little bit more about that. DEXPI is a standard with high ambitions. Today it covers the exchange of information usually covered in process and instrument diagrams. And they have an ambition to grow their scope. They are also based on ISO 15926, at least for the vocabulary, and it's used for exchange. Plants are not just pipes and ducts and things like that. It's also often buildings. And in the construction industry, in the AEC industry, a well-known standard is industrial foundation classes from ISO 16739. It's a building information standard. It's a standard that is built on the same foundation as the STEP standard, the ISO 10303 standard, but it has other semantics and partly other application tools. It's a very well-known standard all over the world, and many governments around the world are demanding information delivery in this standard to accept construction projects. ISO 10303 is the well-known STEP standard, but we mainly talk about a protocol called 239, which is about product lifecycle support. What do you need to know about an asset to be able to maintain it and upgrade it and demolish it in the end? And another standard called Protocol 242, Managed Model based 3D engineering. It's very much about everything you produce when you're designing a product. Everything from documentation, but also mainly 3D models. So we cover with this step standard asset lifecycle with configuration and change management. And the last standard that Anders will talk about is ISO 81346, and there's structuring principles and reference designation. And it's there are parts of that standard aiming to replace the KKS standard of plant industry, and others for the usage of building construction and the classification and reference designation of that. And that's mainly standard is in the category of information management. But I start with 15926. It's been around many years, and it's in a generic ontology applied to oil and gas. It's been driven and funded by oil and gas, but used also in large complex projects, mainly in the US, outside the oil and gas. It's standardized through the ISO organization, and major projects has been Norwegian oil fields, mostly used for reference data, but there are also other uses of this standard for in-house developed tools for life cycle data. You could see here that there are many parts of this standard. Part number 2 is the upper ontology of this standard, and nowadays a lot of emphasis is going into part 14, which is in the end going to be a modernized part 2. This is very much related to the PLCS standard and an ISO standard called 18111, which is about the information flow in a running plant. You could see to the right that the ontology deals with things, and then we have possible individual or abstract objects, and then you can see that the possible individual can be an event, a period in time, activity, physical objects, whole life individual, actual individual, arranged individual, and the physical object can be functional physical objects and materialized object. And the abstract objects are classes, class of individual and relationships. As you see, there is not much engineering language in this top level, so you need to subclass all these classes to define things that an engineer understands, and that's been a benefit, of course, but also a problem when we are applying this standard. SIFOS is a downscaled version of 15926. It's coming from the need in the process industry to have a much better handover process. The process industry is tired of getting tons of documents or PDFs. They like to have data describing the plant that they bought and going to operate. And we can see now, starting from 1-2 years ago, that this is gaining a lot of momentum. And we see that what this is addressing is really needed, and it's a real lean action to start to use this, since you avoid a lot of non-value adding activities. The SIFO standard defines standard classes of things, but not only that, also which attributes and properties each class in the plant, pumps, valves, and so on, tubes, what kind of attributes are needed to be populated, and what kind of properties, and what kind of document types should be assigned to this kind of class of object. And this really helps, and it's we will see in the coming years that this will be a standard way to do handovers in the process industry. DEXPI is more about the connectivity in pipe systems and electrical systems and so on. Is starting from the ideas of an schema, and the diagrams includes connections, and that's what they do very well in this standard. It's also process related, and standards like OPC UA and other information model standards in this area are also using this kind of node link connections to describe how things are connected, how a tube is coming into a pump, how the electrical wires goes to a pump, and how the control mechanisms are related to the pump, for example. This is also something that needs to be addressed to do the digital transformation in the future. This kind of schematics can't be managed on paper or on PDFs. It has to be in databases with data and explicit objects for nodes and links and ports and functional things and so on. IFC, I talked about that. It's coming from an organization nowadays called Building Smart. It is about the components of buildings and infrastructure. Until lately, it's been mainly buildings. You've probably heard about BIM, Building Information Models, and this is the neutral format of a building information model. It is used in construction, facility management, infrastructure, asset management, and so on. And it's mainly on exchange format also. The application is worldwide. It's one of the most used step-related standards, and it's used the same kind of technology as step, like 10.303.11, which is the modeling language, 10.303.21, which is the exchange format, and so on. This is a mature and very well working standard. And now about the STEP standards, 10.33239, product lifecycle support, is really coming from the technical asset management, and is applied in aerospace and defense, and in general industry with long-living complex products. It's standardized in ISO, and major projects are cross and international industry application, and it's gaining momentum more and more when industry is doing digitalization. And all the STEP standards are of course related to this one, but also other standards, like I talked about 15926. This is designed to deal with reference data, supporting using reference data from 15926, and as well as SIFOs and things like that. The 242 is a part of STEP with the most advanced 3D modeling. It's very much today used in aerospace and defense and automotive, and every CAD system can read and write 3D shapes in neutral format according to 242. It is the replacement of a standard called AP214, which was the replacement of a standard called AP203. So this is the latest one, and the one should be applied. Worldwide application, of course, together with all CAD systems, and it's a part of the ISO 10303 family. And 1346 is a very interesting structuring principle. It's not an information exchange format. It's more about how you should structure data, and many tools are now starting to look into this. We are using this together with 239 Eurostep and also IFC 4.3. It's a very good complement. It's a little bit like the skeleton of the information set. This is just to put this all into context. This is in the middle a digital twin. There is a real plant, or there going to be a real plant, and in the middle we have a data set or a database supporting ISO 50926, PLCS, and ISO 1346. This middle thing is used for configuration management and consolidation. Into this, you can then read object-oriented standards that I've been talking about for the buildings, IVC, for equipments, the AP242, for piping and schematics, DEXPI or SIFOs or things like that, and for connection to the more ERP maintenance system world, we use STEP PLCS. You could look upwards. You see that we could, with the consolidated data coming from different both principal standards and geometric standards, we could consolidate geometric data into a digital twin representation, and that representation on the top is that picture is growing while data is confirmed for sharing in this digital twin. In the bottom, you could see how we can establish a language for a project, for a company, or for a domain, industrial domain, using this reference data libraries. And SIFOS is the handover format to the operator. Of course, they could also take over the digital twin, and that I think will happen more and more. But today they ask for SIFOS data to import that into their maintenance system. But if they were interested to keep even better control over the traceability to early phases, like the requirements and the early designs and so on, it would be better to use this digital twin as a complete handover. But today, industry is asking for SIFOS transfers. Thank you.